Welcome to the next video in our series, Exploring Cimatron for Mold Design. This video is designed to follow the previous video on standard mold bases. Our discussion today will focus on mold splits and bringing a slide assembly in and editing it. Previously, we split the part, creating our parting surfaces, and also included a catalog-style mold base. The approach we will show today for splitting the A and B side of the tool is certainly not the only way to do it, but in general it is a simple way for all types of applications. We will do a direct cut to the A and B plate of the mold by using solid extrude to add material. The preview helps us see that enough material is being added to capture all the details of the part and parting surfaces. We will now use Cut Active to cut the B plate. As we do this, we pick the core side quick split faces, which will automatically grab the entire set of faces as well as the parting surfaces. And again, the automatic preview ensures that we're cutting away the correct side. We will now follow the exact same method to this time cut the A plate. So now that only the A side of the mold and the parting faces are visible, we will now use the same function of solid extrude to add material onto the A plate, ensuring it fully encompasses the part and the parting surfaces. Again, we will use Cut Active to cut the A plate, and as we do so this time, we will pick the cavity side of the quick split faces. Again, it's possible to use other methods to do this. One would be to order the A and B plate oversize when selecting the mold from the catalog. And everything that you've seen can apply to different styles of molds, such as this one for direct cutting to the A and B plate, multi-cavity insert molds, and non-standard custom molds. We are now to the point where we will bring in a slide assembly using a duplicate of a catalog master. This ensures that as we change this slide for this particular job, the master itself always will stay the same. As we position the slide, we have full control over its orientation, how deep it will sit in the pocket, its rotation, also its overall size. Now that the slide assembly is correctly positioned, we will automatically cut the pocket that it sits in, as well as any of the holes for the assembly screws. Additionally, editing can be done in the setup table, changing its overall sizes and other parameters and relationships. We can build lists from catalogs or have our own pull-down lists, and we encourage you to look for other videos on the subject of setup to understand its full capabilities. Here we change the width of the slide assembly, and we can see how it affected the pocket and component locations. One more time, we will go to Cut Active, and this time we will use it to import the quick split slide faces. Now we will chain along the outer edge of these slide faces using composite curve. We will use this curve now to sweep shut-off faces on this part of the slide. We give it a sweep direction and tell it to stop at the face of the slide block. We will use the same series of operations to create the shutoffs on the other side of the slide. And as we do this, these swept faces can be created with a shutoff angle. We will now bring together the quick split faces that are off the imported part, the shutoff faces, and the block that was made from the catalog, all using solid merge. This truly shows the unique hybrid environment of Cimatron. This leaves us now with the task of cutting the shutoff slide faces into the B-plate. We will use the operation of solid cut to first pick the B-plate and then the slide block, and it will cut those shutoff faces into the B-plate. And here we see the successful cut. This method can be used for all sorts of custom mold components, such as lifter assemblies as well. Thank you for reviewing this presentation and for your interest in Cimatron for mold design. We invite you also to review the other movies in this video series.